Okay, in this video we're going to introduce logarithms to you and kind of show you how to convert exponential functions as logarithms and how to convert logarithms back to exponential form, okay? First thing, what is a logarithm? All right, so let's take an exponential form first. When b raised by the power of y is equal to x, so b to the y power equals x, okay? The base of this expression is b, the exponent is y, okay? So the base b logarithm of x is equal to y, okay? So notice the connection between this equation and this equation, okay? The base is b. Notice that's the base of the logarithm, okay? The exponent, y, comes over here, and our actual solution, x in this case, is going to be in that spot right there, okay? So let's give a numerical example. So we know 2 cubed is equal to 8. So if we want to rewrite this exponential in logarithmic form, notice our 2 here is going to be the base of the logarithm. The exponent is going to be the solution. And what was the solution in exponential form goes along with the logarithm right here. Okay? So this equation is equivalent to this equation. Okay? These are the same. Just different ways to write them. Now, we need these different ways because eventually we're going to have to solve exponential equations, okay? And we can't do that without logarithms. Eventually, we're going to have to solve logarithmic equations, and we can't do that without converting it to exponential form, okay? So the relationship between these two is very important as we move forward, okay? Now, there's 2 different logarithms that are used very often, okay? Now, the first thing here, the common log. The common log has a base of 10. Okay, so 10 would be where the b is here, okay? Or 10 would be where the 2 is here, all right? Now, you'll see that on your calculator. You won't see the 10 there as the base. It's the common log. So anytime you see log with no base, the base is understood to be 10, okay? So on your calculator, you're going to see log x. That means the base is 10, okay? The second most used logarithm is what we call the natural log. Now, in a previous video, we introduced the number e, okay? The natural logarithm has e as the base, okay? So logarithm to the base e. Now, the natural log, we don't use the same letters like we did here. We call it ln, okay? ln for natural logarithm here, understood base of e. So if we were to write it out, you'd have a logarithm with the base of e. But on your calculator, if you look at it, you'll see this on one of the buttons, natural log of x. Okay, this just means there's a logarithm with the base e. Okay, some basic properties of logarithms. Okay, and again, if you think about it, if we were to convert this to exponential form, we would get a to the 0 power equals 1. Okay, and that makes sense because anything to the 0 power is 1, except for 0, of course. All right. So if we were to translate or rewrite this to exponential form, we'd have a to the 0 equals 1. A to the 0 equals 1. All right, second property here. A to the first power is a. Okay? So we must raise a to the power of 1 to get a. So again, if we were to translate this logarithmic equation to an exponential equation, base a to the first power equals a. Okay? Third property, log base a of a to the x equals x. So a to the x power equals a to the x. All right, so a to the x equals a to the x if we translate that to exponential form, okay? These 2 functions, recently we talked about inverse functions, and these 2 functions are going to be inverses, okay? So a to the log a of x equals x, all right? And that's one of the basic properties. We're going to use that more later on, okay? So, pause the video here. I want you to try to convert these 4 logarithmic equations, into exponential form, and come back and check your work. Okay, in part A here, we've got a log with a base of 4 of 16 equals 2, okay? So rewriting that in exponential form, we've got our base, our exponent, and our solution. So it would be 4 to the second power equals 16, okay? Translating this to exponential form, we've got base of 2 to the 5th power equals 32, all right? In C, you don't see a base there. Remember, the common log has a base of 10. So if you don't see a base there, it means 10. So 10 to the second power equals 100. All right. And natural log, remember, natural log has an understood base of e. So we'd say e base e to the third power equals e cubed. Okay. All right. Let's move on down to the next page. We're going to do one more set here. All right. Skill 2, where we're going to rewrite these exponential forms into logarithmic forms. Okay. So pause the video here and give these 5 a try, and then come back and check your work. All right, so our base of this expression here, our base of this power is 5. So we'd write log base 5 of 125 equals the exponent 3. Okay, let's try B. Our base is 25, so that's going to go right here. So log base 25 of 5 equals the exponent 1/2. Okay. C, our base is 10. Okay, remember, we don't have to write the 10. That's going to be the common log. So the common log of 1 equals 0. Okay. In D, our base is E, so we're going to use the natural log. Okay, so the natural log of 20.1 equals the exponent 3. And finally here, our base is 4, so we're going to do log base 4 of 1/16 equals the exponent -2. Okay. So do a little bit more extra practice with converting from logarithmic to exponential and from exponential to logarithmic. Okay, we're going to use that a lot over the next few sections.